the concept of a set in mathematics is that assuming you have an entire house, right? So let's say this is a house that you guys maybe you are living in. So within this house, we have so many things. There can be other rooms here, right? So other rooms here, there can be anything you can think of within a house, right? So anything, maybe human beings are inside the house and so on and so forth, right? So assuming this is what we are being called a set. So something that looks like a set is what, maybe anything that you can put another thing inside, right? So that's the concept there, right? So maybe let's say I have a box, or maybe any box, I can put so many things inside this box. So maybe this box can be what, a set, right? So that is the concept of behind what the meaning of a set in mathematics. So coming back to the technical definition here, these are some of the things that contains other elements that you can. So talking about the elements are anything that you can think of, anything that you can put on inside of that box or that house and so on and so forth, right? Okay, now behind that, these are some of the things that you must pay a very close attention to. So set here, we normally use capital letters, right? So A, B, C, D, maybe any letters that you can think of, but the key here, it must be a capital. So we use the capital letters to represent the name of the set. So let's say this is a house, maybe let's say this is your house here. I can say that this A here is equal to your house, right? So that's the definition. We don't use a small letters to represent a set. And once again, these are the notations of what a set, right? So this is a curly bracket, right? So meaning that within this curly bracket, we can put things, people, anything that you can think of within what this set here. That is for now the idea or the assumption behind a set. One, you use the capital letters to represent the name of the set here, and then this is the notation, a curly bracket notation that contains all the elements within. Is that okay? Okay, so perfect. Don't do this mistake by representing a set by small letters, right? So maybe let's say A is it. I see people doing this, which is very bad. We don't use that, right? This is a whiteboard marker, black whiteboard. You cannot say this is a red board marker, right? So something that is true must be true once and for all. Okay, now since that is just a simple concept of a set can be maybe a letter here, let's say capital C, that is equal to, now we know that we use this notation to represent the set here, right? And then maybe this can be 1, 2, 3, 4 and so on and so forth. So something that goes like this is an infinite of numbers. They are more than necessary within the set. So okay, that is just a simple concept behind the meaning of set. If you have a problem, make sure that you ask in the comment section or maybe down below for help. Now at this point, we want to discuss the idea of what a subset. So talking about what a subset, the word sub here, maybe in English, maybe something that sub, it means that you are part, right? So part of something, right? So you are part. And maybe let's say this is a group, an association, then you are part of the group. Is that okay? So that is the idea of a subset. So talking about a subset in mathematics, what it means is that you are part of what, a group, right? So maybe you are part. You already know the meaning of what a set. Alright, so talking about a set here. Okay, back to our idea of a house here. So maybe let's say this is an entire house here. Then if you have a single room, let's say this is my room here, right? Maybe a single room and a one bedroom, anything that you can think of, right? So let's say this is your room here. So this is one room here. So if your room is part of the house here, so this is the entire house, right? So this is going to be the entire house. Okay, so this is the entire house, and then this room is inside the house here. Then we are saying that this room here, your room here, is what we are calling what, a subset, right? So this is what a subset of what, the house. Does it make sense? So meaning that the room is inside the house, right? So maybe mention any or other things, 2 or 3 items that you can think of. Anything within the house here is what we are calling what, a subset, right? So anything, if you are human beings, then you live here, you are also what, a subset of the entire house. Now back into our mathematical definitions here. So let's say we have A here. Now you know the reason I'm using A as the name of the set here. That is equal to, let's say, A, B, and then C, and then maybe 1, then 2, maybe let's say these 3 people are inside this house, which is what, A here. Is that okay? So the numbers and the letters, anything that you can find within the set, just assume that these people are inside of the entire house, right? So we want to show that, maybe let's say we want to determine, or maybe by an assumption, let's say B here is another set. So then we are told that B is a subset of the A, meaning that anything that I can find within this room here are coming from the entire house, which is the A here. You can list anything that you can. Maybe A and B here can be a subset, which is true, right? So you can see that A and B are inside of the A here. So we say that B is a subset, right? A subset of A. Does it make sense? You need to understand this simple concept so that if you come across questions that you want to solve that are more in what letters and numbers form, you should know exactly, you should have that assumption, the idea behind what they are trying to tell you, right? So that is just a simple concept of a subset. So mathematically, this is the notation that we normally use here. So we have A is a subset, so maybe something, a long C, anything that is maybe let's say something. So what it means here is that, look at the definition clearly. You mean that B is inside or A. Is that okay? So A is the entire house, and then B is a part of the house. So don't be confused with what this notation says. So it means that the B is the smaller one. Look at this guy has opened its mouth very wide. So it means that you are inside this the A, right? So B here is inside or A, so meaning that B is a subset of A. In some cases you may have some notations like this. So what it means here is that whatever is inside A here is the same thing that is inside the B, right? So maybe that should be for another video here based on this notation. But the concept is very clear here, that a subset is something that is inside of another thing, right? Okay. Talking about operations on set here is very simple, right? So maybe the concept here is that maybe we know 2 plus or 1, maybe and so on. The additions, the subtractions, multiplication, then division, some of these things that we already know, right? So we know this, and these are operations on what? Numbers, right? Now dealing with a set, now we know what a set is, we know some of the subsets. The operations, meaning that how can we combine 2 or more sets together? That is the key there. Now one operation, the first one, is that instead of the addition and the subtractions in terms of numbers like this, then here we are going to deal with what we call intersections. So intersections. And then we also have something that we call a union, and then we also have something like maybe a complement, or maybe, which is not necessarily the case, a complement here. What intersection here means is that now let's say you have 2 sets. Now I can use the technical term, right? So let's say you have a set here, maybe of course set A, there are people inside, maybe there are so many things inside this house here. Is that okay? Okay, let's use numbers for understanding purposes. So maybe you have 1, 2, 3, and then 4, maybe let's say 5, right? And then we have another set, right? So maybe 2 different houses here. This is one house, so house number 1, and then house number 2 here. So here we have another people. Let's say we have 2 here, and then 3, and then let's say A. So this is A, and then maybe we have another one to be B here, right? So these are 2 different houses here. So now the meaning of the intersection here is that if you are so notorious that maybe you sleep in this house here, and then later and the next day you go and sleep in this house, so those are the 2 notorious people. Maybe the notorious people that normally sleep here, and then later on they go and sleep in the second house. That is what we are calling the intersection, right? So what it means here, we have a notation. So maybe a intersection, maybe something like this, right? So this is what we are calling intersection. These are some of the things that you are familiar with, but the understanding is the most important thing here, right? So A intersection B is equal to for sure you can see that this guy is the only a very stubborn guy who normally sleep in this house and come and sleep in this house as well, right? So the intersection here is 2, or maybe 3 is also there, right? So yeah 3 is there, so you have another 3. right? So is there anything that comes count for the intersection? No, these are the two people that sleep here, and then later on they also come and sleep here in this house. So this is what we call the intersection. Is that okay? Now talking about the union means that we are combining all everything together. So combining everything together means that we are combining members of the house one here and the members of the house two, or into one room. Is that okay? So making the third room. So that's the notation A union or union B. Yeah, that is equal to. So let's count everything together. So one, yeah, and then two, and then three, maybe four, five, and then A, and then B. Now look at something. You have two here, you have two here, so you are the same person. So seeing this thing in terms of what a human beings here is that human beings can never be two. You are the same person, so there's no need for you to repeat this guy and this guy twice in the union, right? So make sure that you avoid that mistake there. Is that okay? Human beings are just one. If you sleep and then tomorrow the next day you go and sleep, in this case here, and nobody can say that you are two, right? You are just one person. Is that okay? So counting that in terms of the union, we are just going to repeat that one just once, right? Okay, perfect. The last thing under this concept here is a complement, right? So talking about the complement here, it is something that you must pay a very close attention to. So maybe these are some of the mistakes that students normally do. So solving the idea of a complement, one, you must need a universal. Talking about the universal, we've already seen the meaning of the universal, combining everything, everybody, anything that is inside the household into one place, right? So now we have the universal here. Mostly we use a U to represent that. Let's say we have the universal to be equal to something that goes from 1, 2, 3, A, B, C, maybe D, right? So anything being combined together. So this is the universal, meaning that these people are inside the house. We don't know where you are located in the house. We don't care about that. All that we know that you are inside this house by name of you. Now let's say you have B here, A, right? So maybe let's say A, and then B, and then maybe let's say 2. Okay, so this is another maybe a room inside of that house. So the house here is the universal here, right? So the universal is the house here, and then you have a room inside of that house by how many people? 3 people, A, B, and then C. Now we want to determine the complements of A. So what's that English name here means is that we have, this is what the room inside the house, right? So complement of A means that anybody that is not inside this room. Now consider this room, that this is your room, right? So maybe let's say your room here, maybe you are 3 in the room. So maybe let's say you and your friend, or maybe your sibling, this is your room. And then the entire house consists of how many people? 1, 2, 3, 4, 5, 6, 7. 7 people are in the entire house. So 3 of you are in your room. Then it means that the rest of the 4 here are the complements of what? A. Right? So that is the meaning. Everybody that is not inside your room is your complement. That is just a simple definition. Anybody that is not inside your room is your complement. So starting from here, we have 1, right? So we have 1. We have what? We have 2 as well, right? So we have 2, and then 2 is not part here, right? So don't do that mistake. 2 is not. So we have 3, and then we have we can circle out. So let's say for now, for understanding, this guy is not there, this guy is also there, and then maybe 2, right? So 2, these are the people that are in your room. So we have 1, and then 3, C, and then what, as well as D, right? As well as this. So this is what we are calling what? The complements of what? Of A. Okay, anybody that is not inside your room is what? Is your complement. Perfect, right? Very simple and straightforward. So always look for the universal first, and then maybe take the subset or the set that they are talking about here. For sure, this guy is a subset of it, right? You agree with me? So the complement is that anybody that is not inside your room, but that person is inside the universal, right? So that's what we are calling what? The complement. Assume you have a here, a room inside this house, right? So this is the picture that I'm trying to say here. So let's say this is an entire house, and then we have a room inside this house here. So meaning that this room is a subset of the house, right? So this is an entire house, right? So let's say this is your room. Is that okay? Let's say this is your room here. Now Coming back to the technical definition here, so let's say the entire house consists of 7 people are inside the house, and then in your room here we have only 3 guys here. Maybe let's say you and your friend, or maybe you and your siblings are inside the room. For sure, you people are inside the house. Does it make sense? So perfect. So talking about the complement of what? A here, that is just a technical definition. So the meaning here is that the complement of A, what it means here, that everybody that is inside the house here, but those people are not in your room. Is that okay? So everybody that is inside the house here, but they are not in the room, are what we are calling what? Your complement. So you can see clearly that maybe 3 people here, you see that 2 is in your room here, you have A in your room, and then you have B also what? In your room here. So the rest of the people that are not in your room are what we are calling what? Your complement. And this is the notation, right? So this is the notation here. So A prime, something of this nature. So okay, so that is also the notations of a complement, or some people use something like this, a complement. So whichever that has been given to you, right? So that is the key term here. So seeing this thing here, you can see clearly that maybe 3 people, right? So maybe three people are in your room, and then the rest of the 4 here, this guy, this guy, this guy, and then this guy, are what we are calling what? Your complement. Right? If you have any issue, make sure that you comment down below, right? So comment for help. This is another mistake we see students doing what in solving question related to a set. So here we call it set builders. Don't panic with this name. All that matters is you must know what they are trying to tell you. Now we have this guy here. Now for sure we know what the reason why we are using a capital letters and then this notation. Now what is inside here is the most important thing. We have x, so that this 1 is less than or equal to x, and then less than what? 8. That is what it means. So the way I prefer reading these double things, that I always stand out what I'm looking for. So this x here are the people within this house, but they must not anybody. Neither you are a white or a black, or you are anything. You are a child, or maybe an adult, or maybe a teenager, something of that nature. Now you must know people that are falling within what this particular house here. Now, for you to determine that is why they give us a condition. We say that the x here, anybody that is inside this room here, must be. You see, the mistake comes from this point here, these 2 guys here. Now, let's go back to the maybe a primary level, or maybe grade 1, grade 2, and so on and so forth. Depends on your location. Now, here we are having what? Let's say 1 1 1. Let's use a different pen here, say, and then 1 1. This means that is less than, right? So 1 is less than what? Less than x. Is that okay? So meaning that 1 here is less than, say, x here can be 0, or maybe and so on and so forth. That is how we read this thing. So what about reading from this side here? So if I want to read the x here, it means that the x is what? Greater than what? 1. Doesn't make sense. This thing way back is something that by definition is less than, right? So it's less than. You say 1. Reading from this side here tells me that 1 is less than what? X here. So what happens if I want to read from this side here? So it means that the x is what? Greater than what? Greater than 1. Is that okay? So always, where we said this side that has a very open or wide mouth here is always the greater than, and the pointed side here is what? Less than. Does it make sense? Maybe the other one goes like this. Let's say something like this. If you have 2, yeah, we can say that 2 is greater than what? Greater than 1. Let's say that is the idea. So this is the meaning of what? Greater than, right? So 2 is greater than what? 1. So reading from this here, you cannot tell me that 1 is greater than, because the meaning of this thing is what? Greater than, right? So greater than, that is the name of this guy here. You cannot tell me that if you want to read from this side here, you say that 1 is greater than 2, which is not true in this case. So depending on where you are reading from, that is one thing you must pay a close attention. So reading from this side tells me that 1 is less than 2 based on the pointed side here, right? So always the pointed side is always the less than, and then the greater than here is always the side that has what? A very open mouth here. So maybe something of that nature. So what happens in terms of the double item? So talking about the double inequality here, so always start from this point here. That is why students always make a mistake in solving questions. So that goes like this, right? So we are looking for the x, people that x here. For sure we are defining the x to be what? An integer. So here you are required to know the meaning of the integer. It can be an odd numbers, so you should know that even numbers or prime numbers and so on and so forth. Does it make sense? So that is what a clear sense of in that case. Solving this particular one is that you must, this is a double, so for sure you move from single before you go to double. So why don't you solve this thing in terms of a single and a one by what I mean by the single? You conquer this part here. Look at something, you conquer this part first, and then when you are done you go and conquer the other one. So here, reading this thing, the x is what we are looking for. So that is why I make a clarification here on how to read things like this, right? So here it means that reading from this side, you can say that 1 is less than or equal to x here, but we are looking for the x. So why don't you start for the guy that is missing? So if the x is missing here, so meaning that reading this thing will give me x is greater than or equal to 1. That gives you the clear sense on what exactly you are looking for. So if x is the people that are greater than or equal to 1 here, and then we know that x is on an integer, we know integers are both negative and positive numbers, right? Okay, so here you see x is greater than or equal to 1. So if you are greater than or equal to 1, then it means you are starting with the 1 greater than or equal to. So greater than means we are going up, so that is 2, 3, and then 4, and so on and so forth. So I would advise you to leave it like this, right? So we don't know where we are going, greater than or equal to. So the second part here, so what I mean by the second part, this guy here dealing with this guy here, is what x is less than what 8, right? So x is less than 8, meaning that we know the x already. So x is the people numbers here, that's the negative and positive numbers, so including 0, right? So that's the definitions of the integer. Now we have that x is less than what, 8. So if you are less than 8, then it means that we are starting from 7, and then 6, maybe 5, and then 4, and so on. Have you seen the way we are able to identify people that we look? So these are the people that we are looking for what they said, right? If you have any question, don't forget to comment in the comment section.